Hi everyone and welcome back to the channel. This is part 6 of the CCNA exam practice question series. I will be covering the topics and questions that will help you pass the CCNA certification exam. In this video, I have compiled a 30 practice questions to get you prepped and primed for the success on the CCNA certification exam. But hold on tight because it's not just about answering questions. We will also be explaining the concepts that will make you feel like Cisco networking superhero. So if you are ready to ace the CCNA exam and elevate your career to new heights, make sure to hit that like button, subscribe to the channel and ring the notification bell so that you don't miss any future content. So let's gear up and dive into the success. Question number 1. What is the path for traffic sent from one user workstation to another workstation on a separate switch in a 3-tier architecture model? And the options are option A, access core distribution access, option B, access distribution access, option C, access core access, and option D, access distribution core distribution access. So in a 3-tier network architecture, we have 3 tiers. The first one is access, then distribution, and then core. So in this question, we have been asked that how the traffic moves from one workstation to another when both the workstation are on different switches. So the correct answer is answer D, access distribution core distribution access. So let me explain it with the help of this diagram that how this is the correct answer. So let's suppose we have a workstation A and another workstation, let's suppose this one B. So the traffic will move such that, so these are basically the access switches, these are the distribution, and these are the core switches. So the traffic will first move to this access switch, then to this distribution switch, okay, and then to this core switch, then to this distribution, and then to this access. So we have the path access, distribution, core, distribution, and access. I hope this is clear. So let's move forward to the next question. Question number 2. Which configuration management mechanism uses TCP port 22 by default when communicating with managed nodes? And the options are option A, Ansible, option B, Python, option C, Puppet, and option D, Chef. So we are talking about that which configuration management solution or mechanism uses the TCP port 22. So remember, the port 22 is basically used by SSH. In other words, which management mechanism uses the SSH protocol when communicating with the management nodes? And the correct option is option A, Ansible. So this is the diagram that shows that how Ansible communicates with the managed node. So the managed node means that the managed host, let's suppose these are different hosts. This is host 1, let's suppose this is placed in group A, host B, host 2, and host, and you can have any number of hosts, and all these are managed using the SSH protocol that uses port number 22. This is the explanation. So Ansible communicates with managed nodes over SSH, which typically operates on TCP port 22. Python is a programming language, while Puppet and Chef use other communication methods such as HTTPS on different ports. So the default port for HTTPS is 443. So the Python is basically, you all know that it is a programming language. These all Puppet and Chef are also configuration management mechanism, but they use HTTPS, not SSH. Question number 3. Which two must be met before SSH can operate normally on a Cisco IOS switch? Choose two options. So the question is that how to configure or what are the conditions for SSH to work on a Cisco IOS switch? And the options are: option A, the switch must be running a K9, that is crypto IOS image. Option B, the IP domain name command must be configured on the switch. Option C, IP routing must be enabled on the switch. Option D, a console password must be configured on the switch. And option E, telnet must be disabled on the switch. And the correct options are: in order for SSH to work or operate on the Cisco IOS switch, we must have, the first option is that the switch must be running a K9 crypto IOS image that supports SSH. And the second correct option is that the IP domain name command must be configured on the switch. So the option A is correct because A is required since only the K9, that is crypto version of the Cisco IOS, supports SSH encryption. And option B is necessary because the IP domain name command is used to generate the RSA key pair, which is needed for SSH to function. And this is how this SSH is then configured. So if your Cisco IOS has not the K9 OS, you cannot use this command. So the two conditions are that you must configure this command, and then the OS must be K9, that is crypto, so that this command can be run. And these are other commands that are then used to configure the SSH. Question number 4. Which 802.11 frame type is indicated by a probe response after a client sends a probe request? And the options are: option A, action, option B, management, option C, control, and option D, data. And the correct option is option B, management. So the explanation is that in 802.11 standard, management frames are used for the processes of discovering and joining networks. A probe request and probe response are part of this process, where the client device probes to discover available wireless networks and the access point responds with network information. So 802.11 is basically the Wi-Fi standard. So we are talking about that which type of frames are exchanged between the client and the access point when the AP responds to a client request. So the correct option is management frame type. Question number 5. Refer the exhibit below. This is the exhibit. Which action do the switches take on the trunk link? So we have these two switches, and this is the configuration done on both the switches. This is switch 1 and this is switch 2. So we have the interface fast Ethernet 01, and then switch port trunk encapsulation 8021Q, and then switch port trunk native VLAN 999, and switch port mode trunk. Again, on the switch 2, we have the same commands, except that here the native VLAN is used as 99 instead of 999. Rest the configuration is the same. So when you configure two different native VLAN IDs on the trunk port, what will occur? And the options are: the trunk does not form and the ports go into an error disabled status. Option B, the trunk forms but the mismatched native VLANs are merged into a single broadcast domain. Option C, the trunk does not form but VLAN 99 and VLAN 999 are allowed to traverse the link. And option D, the trunk formed but VLAN 99 and VLAN 999 are in a shutdown state. So what will be the result of this configuration on these two switches? And the correct option is that the trunk forms but the mismatched native VLANs are merged into a single broadcast domain. So the trunk port will be configured, it will form, but it will have due to mismatch VLAN IDs, it will have some issues, and these are explained here. When there is a mismatch in the native VLAN configuration, the trunk will still form, but it can cause unexpected behavior such as traffic being sent to the wrong VLAN. CISCO devices will not block the trunk link due to a native VLAN mismatch, but it will trigger a warning message in the logs. Therefore, it is necessary that native VLAN IDs on both ends of the trunk match for it to work properly. Question number 6, refer to the exhibit below, and this is the exhibit. Which two prefixes are included in this routing table entry? Choose two. So we have this routing table entry, we have this route, it is C, it is basically directly connected on PortFast Ethernet 01. So which two IP addresses are included in this entry? And the options are option A, 192.168.1.70, option B, 192.168.1.61, option C, 1.64, option D, 192.168.1.127, and option E, 192.168.1.254. So always remember that the subnetting is very, very important and necessary for network administrator as well as for the network exam such as CCNA to pass, because you will encounter the subnetting in many questions and in your professional field as well. So here if you analyze this entry and you basically expand it, the range, this entry shows the network range from 0 to 192.168.1 dot. It is basically 2 raised to the power 6. So 2 raised to the power 6 is basically 64. So we have a range of 64 from 0 to 63. Remember, you don't mistakenly write 64 as here, because the total IP addresses are 64 and the 0 is included in this range. So we will have a range from 0 to 63, and then it is straightforward. You can see that 17 is included in this range. 61 is also included in this range, while the rest 64, 1 to 7, and these all are out of range. So these two prefixes or these two IP addresses are included in this entry. So the correct answers are option A and option B. And this is the explanation I already explained. So the routing table entry in the exhibit is for the prefix 192.168.1.0/26, which means the subnet range covers addresses from range 192.168.1.0 up to 63. The two valid prefixes including this range are 17 and 61. Question number 7. What are two recommendations for protecting network ports from being exploited when located in an office space outside of an IP closure? Choose two options. We are talking about protecting network ports from being exploited. And the options are option A, enable the PortFast feature on the ports. Option B, implement port-based authentication. Option C, configure static ARP entries. Option D, configure ports to a fixed speed. And option E, shut down unused ports. And the correct options are option B, implement port-based authentication, and option E, shut down unused ports. So port-based authentication is also known as the NAC, Network Access Control. It is basically port-based authentication, and the standard for this is 802.1x. It works such that only authenticate whenever a device wants to connect to the network, to the switch, it is first authenticated with a centralized server, and then it is allowed on the network. So this is a security feature. And the second is a common security feature to disable or shut down the unused ports. Usually the switches are of 24 ports or 48 ports or 16 ports, and usually few ports are used and rest are unused. Let's suppose in this case, if we have these ports used and these ports are unused, they are open, then you must disable these ports through configuration so that no one can plug their devices to these ports and access the network. The port-based authentication, that is 802.1x, helps ensure that only authorized devices can connect to the network, while shutting down unused ports prevents unauthorized access by disabling any ports that are not actively being used, as I already explained. Question number 8, refer to the exhibit. This is the exhibit. Which route type does the routing protocol code D represent in the output? So these are basically the routing entries. CCD. One is this. The C is basically for directly connected. This means that this network is configured directly on this interface, and the second, this network is configured on this fast Ethernet 00. So what does the D stands for? Okay, so the options are option A, internal BGP route, option B, /24 route of a locally configured IP, option C, statically assigned route, and option D, route learned through EIGRP. And the correct option is that the D is this entry means that this route is learned through EIGRP. So in Cisco devices, the code D stands for routes that are dynamically learned via EIGRP. The numbers in the brackets, that is this, we are talking about this number, represents the administrative distance and the metric for this EIGRP learn route. Another code for this, if we have O, then O means that this route is learned through OSPF. Question number 9, which type of IP version 6 address is publicly routable in the same way as IPv4 public addresses? And the options are option A, global unicast, option B, link local, option C, unique local, and option D, multicast. And the correct option is option A, global unicast. This is the explanation. The global unicast address in IP version 6 are similar to public IPv4 addresses as they are globally unique and routable on the internet. The other options are not publicly routable. Link local addresses are used only within a local network segment. Unique local addresses are used for private networks similar to IPv4 private addresses. So IPv4 private addresses are basically RFC 1918 addresses that include 10.10/8, 192.168/16, and 172.16/12. So multicast addresses are used for one-to-many communication within a defined scope. Question number 10, refer to the exhibit. Which change to the configuration of switch allows the two switches to establish an ether channel? So we have these two switches, switch 1 and switch 2, and both the switches have the configuration to form an ether channel. So what is an ether channel? When you configure multiple links between two switches. You configure them, and through configuration you combine them into a single logical unit. This has many benefits, including the redundancy, that if one link fails, the traffic still flows. Increased bandwidth, if this is 10G and this is 10G, you have the benefit of 20G. And easy management, you manage this multiple interfaces as a single interface. So this configuration has some issue, although the configuration is done on both the switches, but the ether channel is not up and it is down. So what changes must be done so that the ether channel is formed and the configuration is corrected? So the options are: option A, change the protocol to ether channel mode on; option B, change the LSAP mode to active; option C, change the LSAP mode to desirable; and option D, change the protocol PAQP and use auto mode. And the correct option is that change the LSAP mode to active. Here we can see that we have the mode as passive on both the switches, so changing the mode to active will do the trick. So LSAP mode, this determines how aggressively a switch negotiates to form an ether channel. So LSAP have two modes. Passive, the switch will only form an ether channel if the other switch initiates. So since both are passive, no one will initiate. Active, the switch will actively initiate ether channel formation. The current configuration shows both switches in passive mode. This prevents them from forming an ether channel. Changing LSAP mode to active on both switches will allow them to actively negotiate and establish an ether channel. Question number 11. A packet is destined for 10.10.1.22. Which static route does the router choose to forward the packet? So we want to reach to this destination, that is 10.10.1.22, and we have these multiple routes. So which route will be selected by the router to reach this destination? Option A, IP route 10.10.1.0 and subnet mask is 240, and this is the gateway is same for all 10.10.255.1. For option B, we have 10.10.1.16 and 255.255.255.252, and the gateway is 10.10.255.1. Again, in option C, we have the route 10.10.1.20 and the subnet mask is 255.255.255.252. Gateway is the same. Gateway, you can say this is the next hop. In option D, we have the IP route 10.10.1.20 and the subnet mask is 255.255.255.252, and its next hop is 10.10.255.1. And the correct answer is option C, IP route 10.10.1.20 255.255.255.252, and the next hop is 10.10.255.1. So why this option is selected? Let's break down each entry and you will understand the concept. So in option A, we have the IP route this. So here we have the subnet /28 and this has the range from 0 to 15. So since this has the range from 0 to 15, it does not include 22. In option B, we have the subnet 30 and the range is from 16 to 19. Again, this does not include the IP address 22. In option C, we have the route 10.10.1.20/30. Subnet mask is 30. 252 refer to 30, as is this case. 28 refer to 240. And range here is 10.10.120 to 10.10.123. So this option includes 22. That's why this is the correct answer. In option D, we have /31 or 2540/31, and the range here is from 20 to 21. This also does not include 22. So that's why the correct answer is option C, which include our destination IP address of 10.10.1.22. Question number 12. An office has 8 floors with approximately 30 to 40 users per floor. What command must be configured on the router switched virtual interface to use address space efficiently? So we have that 8 number of floors, and each floor must have maximum of 40 users. So basically the question is about how many IP addresses would you require and which command would suffice the IP addresses, and the options are option A, IP address 192.168.0.0 and subnet mask 255.255.0.0. Option B, IP address 192.168.0.0 and subnet mask 255.255.254.0. Option C, IP address 192.168.0.0 and subnet mask 255.255.255.128. And option D, IP address 192.168.0.0 and subnet mask 255.255.250.224. And the correct option is option B, 192.168.0.0 and 255.255.254.0. Why this is correct answer? Let me break down each options one by one. So total number of IPs or total number of users are, since we have 8 floors and each floor have a maximum of 40 users, so we have total number of 320 users. So we would require 320 IP addresses. So we need to do subnetting to accommodate up to 320 users. We need to choose a subnet mask that provides enough IP addresses. So in option A, we have the IP address 192.168.0.0 and this is the subnet mask. So the subnet is /16. So the number of usable IP addresses are 2 to the power 16 minus 2, 2 raised to the power 16 minus 2, and this is 65,534. So this is sufficient, but these are a lot of IP addresses. We only need 320. So we won't like to use this address because it will waste a lot of IP addresses. 65,000 is too much as compared to 320. In option B, we have 192.168.0.0, 255.255.254.0. This is /23. So here we have total number of IP addresses, usable IP addresses 2 to the power 9. Remember, 32 minus 23, 9. So 2 to the power 9 minus 2, 5, 10. This is also sufficient, but it also has more addresses. We will see if we can have sufficient addresses but less than this. So in option C, again we have the this subnet mask which corresponds to /24, and the usable addresses are 2 to the power 7, 2 raised to the power 7 minus 2, which is 1 to 6. So these are not sufficient since we need 320. And in option D, again we have the subnet of 27 corresponding to 2 to 4, and here we have the usable addresses 2 raised to the power 5 minus 2, only 30. So these two are not sufficient because they have less IP addresses compared to 320. The option B, so these are crossed, C and D. Option B, the option B have 510 addresses and option A has 65,000. So obviously we will choose the option B because it has sufficient addresses and we won't be wasting as many addresses as in option A. So the option B is the correct answer. So again, as I emphasized earlier, the subnetting, you must be expert in the subnetting and you must practice the subnetting, so that in your profession, in your practical field, you can do this type of works. You can configure networks, you can calculate the required IP addresses, as well as for your exam you will also encounter question where you will need to know the subnetting. Question number 13. Which command must be entered when a device is configured as NTP, an NTP server, network time protocol server? And the options are option A, NTP authenticate, option B, NTP server, option C, NTP pair, and option D, NTP master. And the correct option is option D, NTP master. So this is the explanation for all the options. The NTP authenticate, option A, this command is used to enable NTP authentication but does not configure the device as a master server. Option B, the NTP server, this command is used to configure the device to synchronize its time with another NTP server, not to make it an NTP master. NTP pair, this command establishes a peer relationship with another NTP device, allowing them to synchronize time with each other, while the NTP master, this command configures the device as an NTP master server. It specifies the stratum level, indicating that this device will provide time services to other NTP client. Question number 14. Which technology must be implemented to configure network device monitoring with the highest security? So we are talking about device monitoring but with highest security, and the options are option A, IP/SLA, option B, syslog, option C, NetFlow, and option D, SNMP version 3. And the correct option is option D, SNMP version 3. We can implement this to configure and manage our network devices, monitor our network devices with highest security. So this is the explanation for all the options. IP/SLA technology is used for active monitoring of network performance, but it does not provide specific security feature for monitoring data. Option B, syslog, while useful for logging devices events, syslog does not encrypt the message is sent, making it less secure for monitoring sensitive information. NetFlow, this is a protocol for collecting IP traffic information, but like syslog, it does not provide built-in security measures such as encryption. And option D, SNMP version 3. This version of the simple network management protocol includes robust security features including authentication and encryption. It is designed specifically to provide secure monitoring and management of network devices. Remember, the earlier version of SNMP does not provide these security features such as SNMP version 1 and 2. Question number 15. Which two primary drivers support the need for network automation? Choose two options, and the options are option A, eliminating training needs, option B, increasing reliance on self-diagnostic and self-healing, option C, policy-driven provisioning of resources, option D, providing a ship entry point for resource provisioning, and option E, reducing hardware footprint. And the correct options are, we have to choose two options, that the primary drivers for network automation is increasing reliance on self-diagnostic and self-healing, and the policy-derived provisioning of resources. And this is explanation for both the correct option. Increasing reliance on self-diagnostic and self-healing, network automation enables devices to automatically detect and diagnose issues and take corrective actions without human intervention. This reduces downtime and improves network reliability. Option C, a policy-driven provisioning of resources. Network automation can be used to automate the provisioning of network resources based on predefined policies. This ensures that resources are allowed efficiently and consistently and reduces the risk of human error. Question number 16. Using direct sequence spread spectrum, which three 2.4 GHz channels are used to limit collisions? And the options are option A 1, 6 and 11, option B 1, 5, 10, option C 1, 2, 3 and option D 5, 6, 7. And the correct option is option A 1, 6 and 11, and this is the explanation. So in 2.4 GHz frequency range, there are a total of 14 channels that are channels 1 through 14, but only channels 1, 6 and 11 are non-overlapping in the United States and many other regions. Each channel in the 2.4 GHz band is 20 MHz wide, and since the channels overlap, using channels 1, 6 and 11 helps to minimize the interference and collisions, allowing for better performance in wireless networks. Question number 17. Which port type supports the spanning tree PortFast command without additional configuration? And the options are option A access ports, option B layer 3 main interfaces, option C layer 3 sub interfaces, and option D trunk ports. And the correct option is option A access ports. So this is the explanation for all the options. So the access ports, these ports are designed for connecting end user devices like workstations or servers. By default, access ports are configured to automatically go into the forwarding state when they are connected to a device without requiring additional spanning tree configuration. This is because access ports are typically not part of a loopback or redundant topology. Layer 3 main interfaces and Layer 3 sub-interfaces, these ports are used for routing and are not directly involved in spanning tree calculations. They don't support the PortFast command. Trunk ports are used to carry multiple VLANs between switches. They require specific configuration to enable the PortFast command, as they are more likely to be part of redundant topologies. Question number 18. Refer to the exhibit. Which route type is configured to reach the internet? So this is the exhibit. We have this switch 1. This is another switch. This is the router. So we have been asked that which route is configured on this router R1. This is the routing table of R1 to reach this internet. What is the route type that is configured here to reach this internet? Let's suppose this client wants to read the internet via this router. How it will read the internet? Through which route? The options are option A host route, option B default route, option C floating static route, and option D network route. And the correct option is option B default route. So we are basically talking about this route where the next hop is this 10.10.10.18, and this is basically the denotion of a default route. Default route contains all the destination, and it is used when the entry or the route to destination is not available in other entries, then the default route is used. So whenever any device wants to access internet, or for that case anywhere, first of all the configure routes are checked. If the destination is not available through in these routes, then the default route, since the default route contains all the destination. Let me bring up the explanation. So a default route is a static route that specifies the next hop to be used for packets that do not match any other specific route in the routing table. It is typically used to reach the internet or other external networks. Another thing to remember is that internet, if you want to access internet, you cannot configure manually each route towards the internet, since we have here thousands and millions of destinations. You have hundred and thousand of websites, applications, each have different IPs, so you cannot configure all these manually. So that's why when we have a huge external network such as the internet, we normally use the default route. Question number 19, what benefit does controller-based networking provide versus traditional networking? So the controller-based networking is basically the software-defined networking where the a centralized control plane and controller is used as compared to traditional networking. So what are the benefits of SDN? And the options are: option A, it moves from a 2-tier to 3-tier network architecture to provide maximum redundancy. Option B, provides an added layer of security to protect from DDoS attacks. Option C, allows configuration and monitoring of the network from one centralized port. And option D, combines control and data plane functionality on a single device to minimize latency. And the correct option is that the control-based networking allows configuration and monitoring of the network from one centralized port or from one centralized device or location. So this is how the control-based networking looks like. In control-based networking, we have a distinct layer. This is the, let's suppose, control plane, or you can say that it is the control layer. You can also call it a control plane. This is the data plane. So in traditional network, the control plane and data plane, they are on the same device. It means that if you have a switch, both the control plane and data plane resides over here, while in SDN or the controller, in the controller-based networking, the control plane is separated from the data plane and they reside on different devices. So using this control plane or the controller-based networking, you can manage and configure the devices from a centralized controller. So that is the main benefit. Question number 20, what are the two benefits of HRPs? And the HRP, first hop redundant protocol. FHRPs are first hop redundant protocol. We have to choose two options. Option A, they prevent loops. This is basically loops in the layer 2 network. Option B, they allow encrypted traffic. Option C, they are able to bundle multiple ports to increase bandwidth. Option D, they enable automatic failover of the default gateway. And option D, they allow multiple devices to serve as a single virtual gateway for clients in the network. And the correct options are, the first correct option is that the first hop redundancy protocol enable automatic failover of the default gateway. I will explain these in a bit. And the second correct option is that they allow multiple devices to serve as a single virtual gateway for clients in the networks. So how this is done? Let me bring this diagram. So the first hop redundancy protocol works such that you have two routers here, let's suppose R1 and R2. So they are configured such that they both are basically directly connected. They are configured using this protocol and they worked as in tandem with each other. One device works as an active, that is actively configuring forwarding traffic, while other work as a passive. And a virtual IP or gateway is configured on these devices, such as this 20.1. On the client device, let's suppose this is a client, you configure the gateway as this virtual gateway. Although both the devices has physical IP addresses, this is the virtual IP addresses. So what is the benefit of this? that for this client you do not need to configure both the gateway here, only you configure this virtual gateway as shown here. And the other benefit is that, let's suppose now the traffic is being routed through these devices. If this device fails due to any reason, the traffic is handed over, or traffic is processed by this device, and now the traffic goes through this. The client does not see any break or any disruption in the services. So that is the benefit of first hop redundancy protocol. So the benefits, automatic failover. First hop redundancy protocol provide high availability by automatically switching to a backup gateway if the primary gateway fails, such as in this case. This ensures that network traffic continues to flow without interruption. Virtual gateway. First hop redundancy protocol allows multiple devices to act as a single virtual gateway, providing redundancy and load balancing. This means that clients can use a single IP address to access the network, regardless of which device is currently acting as the active gateway, as I already explained. Question number 21. Where does wireless authentication happen? And the options are option A, SSID, option B, radio, option C, band, and option D, layer 2. And the correct option is option D, the wireless authentication occur at layer 2. So wireless authentication such as WPA, Wi-Fi protected access, and WPA2 occurs at layer 2 of the OSI model. This is where MAC addresses are used, and protocols such as EAP, Extensible Authentication Protocol, may be utilized to authenticate devices attempting to connect to the wireless network. So this protocol again is used by 802.1x standard, also known as NAC, Network Access Control, that is used whenever a device wants to connect to a network. When this NAC is used, the device is first authenticated from a centralized server, and then it is allowed. And this authentication most of the time occurs through the MAC addresses and other mechanism. That's why this authentication occurs at layer 2. Question number 22. Which WPA3 enhancement protects against hackers viewing traffic on the Wi-Fi network? So this is the latest Wi-Fi protection standard. So how does this standard protect the traffic from hackers in Wi-Fi network? And the options are option A, TKIP encryption, option B, AES encryption, option C, scrambled encryption key, and option D, SAE encryption. And the correct option is option D, SAE encryption. So the SAE, that is simultaneous authentication of equals, is a new encryption protocol introduced in WPA3. It provides stronger protection against attacks like dictionary attacks and brute force password cracking. SAE also uses a more secure key exchange process, making it harder for hackers to intercept and decrypt traffic. Question number 23. Which statement about link aggregation when implemented on a Cisco wireless LAN controller is true? And the options are option A, to pass client traffic, two or more ports must be configured. Option B, the EtherChannel must be configured in mode active. Option C, when enabled, the wireless LAN controller bandwidth drops to 500 Mbps. And option D, one functional physical port is needed to pass client traffic. And the correct option is option D, one functional physical port is needed to pass the client traffic. So a Cisco wireless LAN controller can pass client traffic with just one active port, even if link aggregation is configured. So this is a diagram just to show you the concept. We have here a Cisco wireless LAN controller. It is connected with the distributed switches through link aggregation using multiple links. This is how it works. But the question here suggests that even if you use one link and configure the link aggregation, it will still work. It will pass the client traffic. You do not necessarily, it is recommended that you have multiple physical ports. But if you do not have multiple ports, even a single port will still pass the traffic and the configuration will still work. Question number 24. Which two outcomes are predictable behavior of HSRP? Choose two options. In the option are option A, the two routers share a virtual IP address. So this is similar to FHRP, first hop redundancy protocol. Further, it will be explained in the explanation. Option A, the two routers share a virtual IP address that is used as a default gateway for devices on the LAN. Option B, the two routers negotiate one router as the active router and the other as the standby router. Option C, each router has a different IP address. Both routers act as a default gateway on the LAN and traffic is load balanced between them. Option D, the two routers synchronize configuration to provide consistent packet forwarding. And option E, the two routers share the same IP address and default gateway traffic is load balanced between them. And the correct options are that the two routers share a virtual IP address that is used as the default gateway for devices on the LAN, as I already explained in a question a while ago. And the second correct option is that the two routers negotiate one router as the active router and the other as the standby router. So this is the explanation for both the option. The virtual IP address, this is for option A. HSRP, that is hard standby router protocol, uses a virtual IP address that is configured on both routers. This virtual IP address is advertised as the default gateway to devices on the LAN. Active and standby routers, HSRP elects one router as the active router and the other router as the standby router. The active router handles all traffic while the standby router remains in a standby state, ready to take over if the active router fails. Again, as I already explained in the previous question, the two routers shares a virtual gateway or a virtual IP, and the clients on the LAN, they use this virtual gateway. They do not use the physical IP addresses of the individual routers, and these are configured as active and passive. One router is active at a time. Let's suppose this is R1 and the other is passive. So at a specific point in time, the traffic is handled by this active router, and if this router fails, then the traffic is routed to the secondary router, which becomes then active. Question number 25. What are two reasons for an engineer to configure a floating state route? I think this is a static route. Floating static route. Let me get back a bit. Choose two options, and the options are option A, to automatically route traffic on a secondary path when the primary path goes down. Option B, to route traffic differently based on the source IP of the packet. Option C, to enable fallback static routing when dynamic routing protocol fails. Option D, to support load balancing via static routing. And option D, to control the return path of traffic that is sent from the router. And the correct options are that the floating static route is configured to automatically route traffic on a secondary path when the primary path goes down, and to enable fallback static routing when the dynamic routing protocol fails. So option A is correct because a floating static route is a static route that has a higher administrative distance than the primary route, allowing it to take effect only when the primary route becomes unavailable. Option C, floating static routes can serve as a backup to dynamically learned routes, providing a way to maintain connectivity if the dynamic routing protocol loses its path. Let's move forward to question number 26. So the service password encryption command is entered on a router. What is the effect of this configuration? Option A restricts unauthorized user from viewing clear text password in the running configuration. Option B encrypts the password exchange when a VPN tunnel is established. Option C prevents network administrators from configuring clear text passwords. And option D protects the VLAN database from unauthorized PC connections on the switch. And the correct option is option A. It restricts unauthorized users from viewing clear text passwords in the running configuration. So when you use the service password encryption, this command is used to encrypt passwords stored in the running configuration of a Cisco router. This prevents unauthorized user from viewing clear text password if they gain access to the router's configuration. What does this mean? That if you see the configuration of the router, the password will not be shown in clear text, rather it will be shown as garbage entry. Question number 27. What does an SDN controller use as a communication protocol to relay forwarding changes to a southbound API? So which protocol is used by SDN controller to communicate through southbound API? And the options are option A OpenFlow, option B Java, option C REST, and option D XML. And the correct option is option A OpenFlow. Let me get back a bit. So this is an SDN controller, and this controller talks with the network devices. This is basically the controller is in the control plane, and these devices, the network switches, basically are in the data plane. This is what we call the southbound API. So this controller talks with the network devices, that is switches, through OpenFlow protocol. This is a standard protocol used for communication between an SDN controller and network devices like switches and routers. The controller uses OpenFlow to relay forwarding changes to the devices, enabling it to dynamically control the network's behavior. Question number 28. Which statement correctly compares traditional networks and controller-based network? Traditional or legacy network and controller-based network are basically referring the SDN, software-defined networking. And the options are option A, only traditional network offers a centralized control plane. Option B, only traditional network natively supports centralized management. Option C, traditional and controller-based network abstract policies from device configuration. And option D, only controller-based networks decouple the control plane and the data plane. And the correct option is option D, that only controller-based networks decouple the control plane and the data plane. So what does this mean? In the SDN, this is basically an architecture of SDN or controller-based network. The data plane and the control plane, they are decoupled or they are separated. They physically exist on different devices. So the controller here is the brain of the network that lies inside the control plane, while in the data plane we have the network switches that are configured or controlled through the controller. While in traditional network, both the control plane and data plane, they resides inside the same device, such as the traditional network switches. They both lies inside the same device and they are not decoupled. In the controller based network, they are decoupled. Question number 29, refer to the exhibit. Which route does R1 select for traffic that is destined to 192.168.16.2? And the options are option A 192.168.16.0/21, 16.0/24, 26.0/26, and 16.0/27. So we want a route that can be used to reach this destination 16.2, and we have multiple routes as shown here in this routing table. So which route will be selected by the router inside the routing table? And the correct option is option D, the 192.168.16.0/16. Although this destination also exists in this as well as in this network, you can also reach to this destination through this route as well as through this route. So why this route is selected? It is because this is destination IP addresses matches all four. If you want to say all four, then this means this is also 16. All four entries in the routing table, but the 192.168.16.0 has the longest prefix, so it will be chosen. This is called the longest prefix match rules. So you can say that, you can remember this, that the smaller or more specific is the route, the more chances of it is that it will be selected. Or for the longest, you can see that here we can see that 27 is the longest prefix, or it is the biggest prefix here in all these, so that's why this is selected. Question number 30, which technology can prevent client devices from arbitrarily connecting to the network without state remediation? And the options are option A 802.1x, option B IP source guard, option C MAC authentication bypass, and option D 802.11n. And the correct option is option A 802.1x, which is also known as NAC, Network Access Control. That is a port-based authentication that allows network devices to connect to network after necessary authentication and state remediation. So this is a port-based authentication protocol that requires client devices to authenticate with a central authentication server before being granted access to the network. This prevents unauthorized devices from connecting to the network without proper authorization. So this is how the IEEE 802.1x work. So this is the switch, or this is the device with which this client wants to connect, and this basically wants to access this internet or LAN. So when the device wants to connect, this here we have a centralized authentication server. The authenticator asks this authentication server whether to allow or deny access, and based on the configured policies and the state of the device, it will either be allowed to access the internet or LAN, or either it will be blocked. So this is the concept of 802.1x, or also known as NAC, Network Access Control.